Hey everybody, this video is going to be on the Pythagorean Theorem and its converse. We are moving into a chapter that's all about right triangles. So we'll start with something that you're fairly familiar with, and then we'll be talking about special right triangles and actually dipping into some trigonometry later on as well. So the Pythagorean Theorem basically states, first of all, you have to have a right triangle. So we're going to interpret all this up here into a picture. So if you have a right triangle, let's go ahead and name this. I'll call this A, B, and C. So if triangle A, B, C is a right triangle, then it must be true that if you take each of the legs and square them, so remember the legs are the sides that make up the 90-degree angle. So that guy's a leg, this guy's a leg. It actually turns out that once you square each of those and you add them together, it gives you the hypotenuse squared. So the hypotenuse is the longest side of the right triangle across from the 90-degree angle. So then the legs squared plus the legs squared is equal to the hypotenuse squared. And we usually call our legs A and B. And then our hypotenuse is C. So A squared plus B squared, those lengths squared, added together equals the hypotenuse squared. Let's check out some examples. Number 1 says, find the missing side length of the triangle. So looking at this, we are given a leg here and a leg here because they're the sides that are making up the 90-degree angle. What we're missing is the hypotenuse. I'm going to go ahead and call that C. A and B can be switched around. And we'll throw it into A squared plus B squared equals C squared. So I decided to call my A value 20. So we'll do 20 squared plus 21 squared equals C squared. 20 squared is 400. 21 squared is 441. And we got C squared there. We'll add those together. And then in order to undo a square, we're going to take a square root. And it should come out to be 29. Ooh. As our missing side. So this guy is going to be 29. Now in this particular case, we ended up with a right triangle where all of the sides were all nice whole numbers. And a lot of times when you're actually applying the Pythagorean theorem, you won't end up with that case, like at least one of your sides will be a decimal value. But when it does happen where you have these nice whole numbers for each of the side lengths, we call it a Pythagorean triple. So let's go ahead and write that definition down. Pythagorean triple is when you have whole numbers, A, B, and C are the variables that we're using, that satisfy the equation A squared plus B squared equals C squared. So some common Pythagorean triples, and when you say the three numbers, the biggest number in that triple has to be the number that goes along with the hypotenuse. The hypotenuse is always the longest side of that triangle. So a really common one is 3, 4, 5. It actually comes up a lot on the ACTs if you plan on taking those. Other ones that come up, you could have like a 5, 12, 13, 8, 15, 17, 7, 24, 25. And then you can imagine you could go through and like maybe I'm picking on the 3, 4, 5. I could choose to multiply each of those numbers by the same number, and it would come up with a new set of Pythagorean triples. So like I could go through and multiply each of these by 2. So another possibility, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. A 6, 8, 10 is also a right triangle that works out. Everything's a nice whole number. So those aren't bad to keep in the back of your mind. It's really nice when you're doing the Pythagorean theorem and it does come out to be one of those nice whole numbers. but that won't always necessarily be the case. So let's take a look at a problem where it isn't the case. So in number 2, it says, find the value of y, express your answer in simplest radical form, which is something we already worked with. A little bit more challenging here, one, because we know that the answer is not going to necessarily come out to be a whole number because of how the directions are worded. And then also they give you this side length right here as a radical already. So let's see how that plays out when we put this into our Pythagorean theorem. But I'm just going to go through, I'm going to call this side A, I'm going to call this side B, and then the hypotenuse has to be C. So we'll do A squared plus B squared equals C squared. A is 6, so we'll do 6 squared plus B is the y that we're trying to find. And then C is the square root of 85 squared. So 6 squared is 36. Now, if you're trying to square something that you're taking the square root of, these are like opposite operations, and so they essentially simplify each other out. And so you're just going to end up with 85 there. And we'll subtract 36. Ooh, this is going to end up being a nice number. Go ahead and take the square root. And so you did get a nice answer of y equaling 7. Let's look at an application problem. This one kind of comes up a lot with these right triangles. It says a square has a diagonal length of 12 centimeters. What is the side length of the square? Give your answer in simplest radical form and draw a picture to help you out. So we're dealing with a square. We'll draw a picture of a square. We know a square has all the sides being the same. We know all the angles are 90 degrees. And they talk about a diagonal here, so I'm going to go ahead and draw in a diagonal from the lower left to the upper right. You could also go the other direction if you wanted to. Now they tell us that the diagonal, this guy, is 12 centimeters. We have to figure out what a side length is of the square, and they're all going to end up being the same. Let me highlight the right triangle, this right triangle here. Let's use this one. That's happening. So it's kind of an interesting situation because we're used to running the Pythagorean theorem and be given two sides, and then we have to find the missing side. But this time we have two missing sides and we know the hypotenuse. But the one advantage that we do have right now is that these two missing sides, we know because they're part of the square, they have to be the same length. So I'm actually going to call this length x, and if that length is x, this also has to be x because they're supposed to be the same. I'm going to write down my Pythagorean theorem. Now, A and B are going to end up being these sides here that are both labeled as x because they're the legs. So we'll do x squared plus x squared equals the hypotenuse 12 squared. Now, this is kind of tricky for students, especially if you haven't had a lot of experience with this. We're adding two of these x squared. So we're just asking ourselves, how many x squareds do I have? I have two of them. So I'm going to write this as 2x squared equals 12 squared is 144. Also kind of a new situation might be for you on how to proceed with solving this. So it's 2 times this amount. So I'm going to divide by 2 on both sides. And then I'm going to take the square root of both sides. And I was instructed to give my answer in simplest radical form. So if you try to take the square root of 72, you're going to end up with a decimal number out. So we need to come up with two numbers that multiply to 72, where one of them you could take the square root of. So one of them is a perfect square. So you might have to spend some time like listing out perfect squares. Like 2 squared is 4, 3 squared, 9. That's supposed to be a 5. So these are all perfect squares. So as you're trying to figure this out, you take 72 and maybe try dividing by 16 to see if 16 will go into it. If you spend some time with this, you'll find that the biggest perfect square that goes in there is going to be 36. So I'm going to change this into 36 and 2. And the square root of 36 is 6. And then we've got root 2. And that is going to be our side length that was missing. So you'll have a couple problems in your assignment where you're just running the Pythagorean theorem in different ways. You're finding a missing side length. Watch out for scenarios where you have to simplify the radical. Then they also talk about a converse of the Pythagorean theorem in this section. And so if you think way back to first semester, converse means reverse. So the Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. The converse just flips that around. So it says if a squared plus b squared equals c squared, so you've got these this triangle, you got these three sides, and you throw them in the Pythagorean theorem, and if one side really does equal the other side, then what you could say is that your triangle, and I'm going to use ABC because we got this picture down here, is a right triangle. So they'll give you side lengths and then just ask you to decide whether it works in the Pythagorean theorem or not. Let's look at a problem like that. Number 4, it says a triangle has side lengths 85, 84, and 13. Is the triangle a right triangle? We'll grab a squared plus b squared equals c squared. It is really important that the biggest side length, so in this case 85, does go in for the c squared when you're checking this. The other two, the order is not important. And this is a question that you're asking yourself. You don't know if it's going to work or not. 85 squared gives you 7,225. 84 squared is 7,056. 13 squared is 169. Then you'll have to add these two together. It'll give you 7,225, 7,225. And so in fact does work in the Pythagorean theorem. And so what that means is that this is a right triangle. So the answer to the question is yes. And then you could say something as an explanation, works in the Pythagorean theorem. There's also a couple other spin-offs of this theorem that tell us things about the triangle. So if they're equal like this, then it's a right triangle. But you can also tell if a triangle is obtuse, so it has an angle that's greater than 90 degrees in it, or if the triangle is an acute triangle where all the angles are smaller than 90 degrees. So let's look at what that's all about. So it says, if the square of the length of the longest side is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. And again, this is what an obtuse triangle looks like. It has an angle in there that's bigger than 90 degrees. So in this case, that's C down there. But essentially, you're still kind of using the Pythagorean theorem, so you're thinking about a squared plus b squared. But when you add those up, they actually end up being smaller than c squared. And if that's true, what it tells you about your triangle is that you have an obtuse triangle and one of the angles is really large. Likewise, you could do the same kind of thing and decide that a triangle is an acute triangle. So if you look at the picture down here, an acute triangle, all these angles in here are less than 90 degrees. And so you do a squared plus b squared, and that ends up being bigger than c squared. Then you know triangle A BC is acute. So we're going to look at some problems where we have to decide whether it's obtuse, acute, or right. So if it equals, both sides equal each other, it's right. If the c squared is smaller, then it's acute. If c squared is bigger, then it's obtuse. So we'll start with this guy here. So I'm going to do a squared plus b squared, and I'm going to compare that to c squared. Maybe we'll put my c squared over here because that's how I was doing it before. The c has to be the biggest value, so 14 has to go in place of c. And then I'll have 6 squared and 11 squared there. And I'm comparing these, like I don't know what's happening comparing these. So 14 squared is 196. 6 squared is 36. 11 squared is 121. Adding these together give us 157, and then we got 196. So comparing these, this number is bigger than the 157. And so it looks like c squared is kind of taking over everything. So what that tells us is that this particular triangle is obtuse. Check out part B here. Again, we're going to do a squared, b squared, c squared, compare them to see what happens. The c value has to be the biggest value, which is 9 in this problem. 9 squared is 81. This is 49. This is 64. I'm going to leave that blank actually. Add those together, 113 is what comes out. So comparing 81 and 113, 113 is bigger. And so the c value here is smaller. When the c squared value is smaller, then you have an acute triangle. And so this concludes what I wanted to talk about with the Pythagorean theorem and its converse. Thank you for watching.